In the last two chapters, in chapter 2 and in chapter 3, we found theta when we were given a value for either sine, cosine, tangent, secant, cosecant. For example, you were maybe given something like the sine theta equals 1/2. And we had to figure out when that would happen.
Jonathan Johnson.
All right, so do you guys remember seeing this? And we had to ask ourselves two things. When is the sine 1/2, meaning what family? And we know that that is when we have the point square root of 3 over 2, 1/2. And that happens in the pi over 6 family. But then we also had to figure out when it was positive, because there was more than one time that this could occur. Remember, these are circular functions, so they repeat themselves and repeat themselves and repeat themselves. And so 1/2 is, sine is positive in the first and second quadrant. In the other ones, it is negative. So I would get my answer, theta, equaling pi over 6, that's the first quadrant, and theta also equaled 5 pi over 6, that's the second quadrant. Again, ring a bell. Do you remember these? Okay. Do we need to draw the picture again with all the families, or you guys pretty much have that figured out, or you can take out your, reference it if you need to. Now, like I said, these are circular functions, and what we answered here is one lap around the unit circle. That means that my answers are going to fall between 0 and 2 pi. So that's what this is. One lap around the unit circle. That's between 0 and 2 pi, not including 2 pi. But this thing can go around. We've already gotten ourselves to 5 pi or 5.5 pi. We can go around and around and around. And so when we need to talk about all solutions, all values, all possible answers, we need to consider the fact that we can just keep getting back to that same point by going one lap around the unit circle. So when I do all values, my theta is pi over 6, yes, but it's also pi over 6 plus 2 pi, because 2 pi would get me right back to that, plus 2 pi more, plus 2 pi more. This goes on and on and on and on and on forever. So we add 2 pi to our answer. But I can't just add 2 pi once, because, again, these are circular functions. This answer can repeat and repeat and repeat and repeat. And so I'm going to add 2 pi repeatedly. And so I just use a variable. You can use n just as well. I always use k. So it's, I'm adding 2 pi k times. Well, what is k? K is 1 time or 2 times or 3 times or 4 times, or it's backwards 1 time or backwards 2 times, and those numbers are all integers. And I showed this symbol this way. This, again, in math looks like a foreign language. It's just telling me that k is an element of the numbers called the integers. And it might have been a while since you talked about what integers are in a class, but integers are all the positive and negative whole numbers. And so if I do the set of integers, which we use z for as the symbol, because why not, right? Well, I is taken, so we can't use I. I is for irrationals. And so capital I is irrationals, lowercase I is imaginary. So z is what they have left, so integers. And integers is the set of numbers that go from negative infinity all the way through all the negative whole numbers, all the way up to positive infinity. So that's our set of numbers known as the integers. And again, all this is saying, this is us translating this language of math. This is telling me that theta is pi over 6, and it's pi over 6 plus 2 pi, and it's pi over 6 plus 4 pi, because that k is 2, and it's pi over 6 plus 6 pi, and it's pi over 6, and this goes on and on and on and on and on forever, infinitely in both directions. Now I want to remember that my other value that we got for this was 5 pi over 6, and I do the same thing for that. I only need to write the k as an element of the integers. So I am going through the process of solving the same way. It's just that when I want to list my answer, I want to make sure that I cover every possible answer out there. And aside from trying to list them all, this is the most efficient way to do that. Okay? So basically, to your answer, you'll add plus 2 pi k. Most of the time. There are little occasions where things change, and we'll talk about those as we come across this. All right? So let's jump in. We are going to be solving in our first section for all solutions. We want our answers to be in radians, and this problem looks a little bit different. So when I'm solving these, I'm now getting myself or putting myself in a position where I have more steps or more things to work with. I consider the tangent of theta to be the variable that I'm trying to solve for. This is what I want to look for. I actually want to look for theta. So when I do problems like these, what I like to do sometimes is I just rewrite it with x, and I think algebra. So let's not kind of clutter our brain up with the tangent part of it at this point. Let's just think, how do I get x alone? And I would do that by adding 4. And of course, you do not have to show these steps, because at this level, you definitely can solve a one-step equation. I'm certain of it. And so I get what I'm looking for. I want, or x is equal to 1. This is where I have to go back into the pre-calc mode and say, well, I'm not really solving for x. I'm actually solving for the tangent of theta. And so I want to figure out when the tangent of theta is 1. So again, I'm going to work my way through until I get a solid number, and then I'll bring the trig back in and go back to what we did in the last 2 chapters. So when is the tangent 1? Pi over 4. When is the tangent positive? First and third. Yep. So this is the pi over 4 family in the first and third quadrant. So again, this is the same process that I went through the last time. So my theta answers are pi over 4 and 5 pi over 4. But I want to get back to those places, so I write this as plus 2 pi k, plus 2 pi k, where k is an element of the integers. So it's a little addition on the end. Now, I did say that most of the time it will be like this, plus 2 pi k. There are instances where our answer can be written in a different form. And that is, if I envision where these two things are, here's pi over 4, and here is 5 pi over 4. How far are these guys apart? Exactly 1 pi. So on occasion, you will see this written in a more compact form, and that would be pi over 4 plus pi k, where k is an element of the integers. So this is an acceptable answer. And this is an acceptable answer. And if it's multiple choice, you might get one of each. But before we move on, I want to back up to that first problem that we did and talk about it. I can't do the same for this problem because here's pi over 6. Bless you. And here's 5 pi over 6. And these guys, I can figure out how far away they are, but they're not an even pi away. And then in addition to that, to get around to the next one, to get back to that spot again, it's not the same length of an arc. So this has no shortened version, but this tangent one does. And if you remember when we were graphing, the period for sine and cosine was 2 pi, but the period for tangent and cotangent was half that. That's kind of the same concept going on here, okay? So it's all about how long it takes it to repeat itself or get back to where it was. All right, so let's start cruising. I need to solve this next one. I'm going to rewrite it with x and then solve algebraically. I do the math, and then I put my trig back in there. You're going to see the answers repeat so often. You don't have a whole lot of answers that we're going to get. A half, negative a half, square root of 3 over 2, negative square root of 3 over 2, square root of 2 over 2, negative square root of 2 over 2, 0, 1, negative 1. We don't have a whole lot of things to go with now. So we kind of saw this before. When is the sine 1/2, pi over 6? The difference is now it's negative. When is the sine negative? Third and fourth. So my theta is 7 pi over 6 and 11 pi over 6. And if this was with one lap around the unit circle, I would stop there. But because this is all solutions, I will add 2 pi k. And k is an element of the integers, so everybody knows. A lot of people ask, do I have to write that? Yes, you do. You need to when you answer it because it's important to define what your language means here. So k is an integer. It's just a variable that changes. It could be 1, it could be 2, it could be 3, it could be 4. I cannot write this more compact because it's sine and it's not evenly spread out. I don't have pi between them. Again, if I look at where these are, I am here, and that is not pi apart, and it's not the same distance if I went the other way. So final answer. All right, keep moving. People get afraid when they see these. Like, oh man, what do I do? Well, we've talked about this before when we were doing identities. Let's break apart that division. This is the same as 3 plus, I'm going to put it in x. And that's 6 over 2 plus the square root of 3 over 2. See what I did? We've done it before. Well, this is 3 plus x equals 3 plus the square root of 3 over 2. Get rid of the 3's because they're the same on both sides. So x is the square root of 3 over 2. And then that means that I am trying to find when the cosine is the square root of 3 over 2. So the cosine is the square root of 3 over 2 in what family? Pi over 6. And in what quadrant? Positive. First and fourth. So theta is first quadrant, fourth quadrant. Add my all solution ending. And finish my answer. We've got another tangent again. So negative 2 plus x is negative 6 over 3 minus the square root of 3 over 3. Or negative 2 plus x is negative 2 minus the square root of 3 over 3. Cross out my negative 2's. I'm looking for x equals negative square root of 3 over 3, except I'm not solving for x, I'm solving for tangent. Remember, when we do these, we have to consider what family, when I put the sine over the cosine, will reduce to this. So it is either the square root of 3 over 2 over 1/2, or it is 1/2 over the square root of 3 over 2. Oops, gotta put it on where you can see. This one equals the square root of 3. The next one equals 1 over the square root of 3, and it looks like this guy is the one that we want. So when is the sine 1/2 and the cosine square root of 3 over 2? Pi over 6 again. And in what quadrant is the tangent negative? That happens when the sine and the cosine have different signs, second and fourth. So theta is 5 pi over 6, and theta is 11 pi over 6, plus 2 pi k, plus 2 pi k. K is an element of the integers. Acceptable answer. Or theta is 5 pi over 6, plus pi k. K is an element of the integers. So when you solve for tangent, you can always automatically cut your answer in half by using pi. As you add, cotangent would be in the same boat. There are occasions with sine and cosine too, if you land on the axis, like when cosine is 0, then that's when those are pi apart. When sine is 0, that's when those are pi apart. Okay, so up next, we're going to get into some more complicated solving. And this is where people get a little nervous and a little uncomfortable, but it's all right. And again, like I had said, if you put a variable in and then solve for your variable and then revisit it, it makes things a little bit nicer. Okay? So here I am with this guy. It is... I want to figure out when 0 equals x squared minus 2. And so 0 equals x squared minus 2 when 2 is x squared. Good with my math? And then I'll take the square root of both sides. So that's the square root of 2 is x. But don't forget, it's plus or minus. And honestly, again, I think I say this every once in a while, and I'm saying it again, about 50% of you are going to forget the plus or minus, and you're going to lose half the points because you only have half the answer. If you take the square root, remember, keep that in your brain. Don't forget plus or minus. So what I'm looking for here is, when is the cosecant of theta equal to the square root of 2, and when is the cosecant of theta equal to negative square root of 2, and when do we see the square root of 2? Pi over 4 family. So I know that this is the pi over 4 family, or I'm pretty sure about it. I can double check by rewriting this as sine. So this would happen when the sine is 1 over the square root of 2, which when I rationalize my denominator, I get the square root of 2 over 2. That's exactly what I expected, okay? So I could go through that with the sine. So it is the pi over 4 family. And then it's, when is the cosecant positive? Well, it's the same as when the sine is positive. So it's pi over 4 in the first and second. But then it's also, when is it negative? So it's in the third and, fourth as well. Okay, so how many answers do I have here? 4 answers. So I can write this as theta is first quadrant pi over 4, and second quadrant 3 pi over 4, and I'm running out of room, and third quadrant 5 pi over 4, and fourth quadrant 7 pi over 4, plus 2 pi k, plus 2 pi k, plus 2 pi k, plus 2 pi k, and k is an element of the integers. Again, if I think about where these all are, I could shorten this one up quite a bit. If you don't want to think about it, that's fine. You can always write it in this fashion. But if I'm looking at this, here's pi over 4, here's 3 pi over 4, here's 4 pi over 4, 5 pi over 4, here's 8 pi over 4. They are all how far apart? So I could write this as one answer. Again, if I think about their location, theta could also be pi over 4 plus pi over 2k. K is an element of the integers. I'm sorry about the lack of room. That was not good planning. And again, you could also even write this as pi over 4 plus pi k, and then 3 pi over 4 plus pi k. There are a lot of different ways that you can write it. If you feel like, no, just right now I want to settle in with the 2 pi k, great. That's fine. Like I said, I'll accept that as well. And we're done at what time today? 07. And that clock is right? It's 10:18. Okay, so yeah, that clock is right now. All right. We're going to just do a few more, and then we'll get ready for the quiz. Okay? So a few more. Here we are. 1 plus tangent squared theta equals 5 tangent squared theta, or 1 plus 4x squared equals 5x squared. I'm just replacing the tangent with x. And so 1 equals x squared when I subtract the 4x. So I take the square root of both sides. That leaves me with square root of 1 is 1, plus or minus 1 is x. Again, I'm taking the square root of both sides. And that leaves me with 1, but I don't want to forget the plus or minus 1. Don't forget it. Don't forget it, don't forget it, don't forget it. Again, I'm not solving for x, I'm solving for the tangent. And when is the tangent positive or negative 1? Or when is the tangent 1? When is the tangent negative 1? And I get, again, the pi over 4 family. And I can write it the long way. It would be pi over 4, and 5 pi over 4 is when it's positive. It would be 3 pi over 4, and 8 pi over 4 when it's negative. Sorry, 7 pi over 4. I don't know what I was thinking there. And all of these could be plus 2 pi k. K is an element of the integers. Totally, totally, totally acceptable answer. Or I could do theta is pi over 4 plus pi k, and theta is 3 pi over 4 plus pi k. K is an element of the integers. Boop, boop, boop. Or I could write it the same as I did the last one. Good? Okay. Do whatever feels the most comfortable to you. All right? Okay, so again, a couple more. I've got a secant. Secant squared. I'm going to rewrite this in terms of x. And so this is 0 equals 2x plus x squared. When I have multiple x's in a problem, sometimes I'm going to have to factor to solve. Up until now, I just had an x squared and a value, and all I had to do was take the square root on both sides. On a problem like this, I'm going to have to factor something out. And so what this looks like is, I'll pull the x out, and I get 2 plus x. Oops, that's 0, not theta. So 0 is equal to x times 2 plus x. I'm applying the zero product property. When you apply the zero product property, that means that you have to have it set equal to 0. And if your, in this case, binomial is equal to 0, and I factor it out, then each factor has to equal 0. So either x is 0 or 2 plus x is 0, meaning x is 0 there, or x is negative 2. Again, I'm not solving for x, though. I'm solving for the secant. So once I factor that out, apply the zero product property, I'm just basically going back to algebra when I'm doing this solving. Then I can go back in and figure out when is the secant 0 and when is the secant negative 2. And so the secant is the reciprocal of the cosine. So the reciprocal of the cosine, I want to look for when the cosine is undefined and when the cosine is negative 1/2. When is the cosine undefined? Think of a cosine graph. Are there any asymptotes in a cosine graph? Is it ever undefined? No. If there are no asymptotes, it's never undefined. This will never happen, therefore we can ignore that. Okay? Now I'll do this one. When is the secant negative 2? That's when the cosine is negative 1/2. The cosine is negative 1/2 in the pi over 3 family, and in the second and third quadrants. So my theta is 2 pi over 3, and my theta is 4 pi over 3 plus 2 pi k plus 2 pi k. K is an element of the integers, and done. I am going to skip 8 for now, not because it's not doable, but I want to address 9 and 10 in this limited time that we have left, okay? And then we can revisit something like 8 tomorrow. You just have to put in 2 variables and you solve for the 2 variables separately. But what do I do if something is done to the angle? Remember when we were graphing, that changed the period of the graph, that changed how long it took it to repeat itself. And we based it off of the unit circle. And this is saying that the sine is going to repeat itself 4 times in a normal lap around the unit circle. So I have to consider that when I'm doing my plus 2 pi k part of it. Just like when we were looking for the period, I'm going to take that value and divide my 2 pi by that. So instead, at the end, I'm going to be adding pi over 2k. Okay, so that 4 changes what I add. It's also going to change a little bit how I solve. So if I'm going to work through this problem, I'm going to start by putting in x and solving. I don't want to neglect the 4, it's still part of it. So I want to know when, the same way, when is the sign 1/2? Repeat, repeat, it's pi over 6. When is the sign positive? In the first and the second. Except for I didn't solve for theta, I solved for 4 theta. I got my answers. I don't want 4 theta. I want theta. So I do a little more algebra. Divide by 4. Do the same thing on the next one. Divide by 4. And add my ending. So having that number in front of the angle changes things in 2 spots. It changes what we add to the end, and it changes the actual family that we're looking at. So I have to get theta alone, so I have to address it up here with the period part of it. I have to address it down here with the theta part of it. We'll do one more of those. And then, like I said, I'm going to stop and let you guys get ready for your quiz. So I am going to start this the same way. X equals negative 11/2, and x equals, a lot of pi over 4 answers in this one, and pi over 6s. No pi over 3s yet. Did we have? Okay. So when I add, that would be 10/2, so it's negative 1/2 here. Solving for the cosine. Oh, I've got the pi over 3 right now. I do want to remember this guy here, so it's plus 2 pi k, but over 2. So I'm going to end up adding pi k in the end. So that 2, oops, okay, there, plus pi k. All right, so when is the cosine a half? Pi over 3. When is the cosine negative? Second and third, yep. So 2 theta is, second quadrant pi over 3 is 2 pi over 3. And 2 theta is the third quadrant pi over 3, which is, oops, I put 6, I don't know why. 4 pi over 3. And then I'm going to get rid of that 2, so divide by 2, divide by 2. So theta is 2 pi over 3 cut in half gives me pi over 3. Or 2 pi over 6, which you can reduce. And then 4 pi over 3 cut in half gives me 2 pi over 3. Plus pi k, plus pi k. K is an element of the integers. So a little bit more algebra thrown in with today's stuff, and then a little bit of thinking about moving around your quadrants. We are going to work a little bit more on equation solving tomorrow. You're also going to get your review tomorrow, and your test will be on Thursday.